Hello and welcome to Otten Math. In this edition of Otten Math, we're going to take care of the second part of Chapter 5.5, Evaluating and Graphing Log Functions. So I want you to take a look at this formula for translated log functions, and the formula is log base b of x minus h plus k, where h represents the horizontal shift. And remember, this value here in the formula is negative, so if you have an x minus 2, then the shift is going to be 2 units horizontally to the right, or positive 2 units, and then plus k, so the k value represents the shift vertically. So again, in the example, y is equal to log base b of, in parentheses, x minus 2 plus 4, shifts the graph 2 units to the right and 4 units up relative to the original parent function, which would be log base b of x is equal to y. All right, so the translation's all in relation to the original parent function. So what I'm going to have you do is I'm going to have you sketch two functions, y is equal to log base 2 of x, and y is equal to log base 2 of x minus 2 plus 4. The first thing you need to do when you're graphing these is to rewrite these in exponential form. So that's what I want you to do now. Then once you get them into exponential form, you're going to create a table. I'm going to give you the values in just a moment. So please rewrite these two functions in exponential form. All right, so you should get 2 to the y is equal to x, and in the second function you'll get 2 to the y minus 4 plus 2 is equal to x. All right, so we're going to use these two functions equal to x to create a table of values. Now the input in this case is going to be y, and then the output is going to be x. So these end up being inverse log functions. So please take a moment. I'm going to pause here. You can fill out the table, and then let's take a look at the resulting graphs. All right, so I filled out the table. You can check your work here and pause for a moment if you'd like. Okay, so we're going to take a look at the two graphs. 2 to the y is equal to x is in blue. These are rough sketches. And then y is equal to log base 2 of x minus 2 plus 4 is in black. And you can see that there are two things that have happened, two shifts that have happened. One is the blue graph is shifted to the right by 2, so you can see this shift horizontally to the right by 2, and then up 4. So the black line represents y is equal to log base 2 of x minus 2 plus 4, and that graph is shifted to the right 2 and then up 4. And now let's talk about the domain and range of the two functions. So if we take a look at the domain of 2 to the y is equal to x, we can see that x has to be greater than 0. So there are no values for y which we can substitute in to get a result for x that's 0 or less than 0. So our domain is going to be x has to be greater than 0. And in this case, y is going to be all real numbers. So you can supply any value in for y and get a real number result out for x. So domain is x is greater than 0 and y is all real numbers. Now this compares to the exponential growth and decay functions, or let's say the non-inverted log functions, where the domain was all real numbers and y was all values greater than 0. So we're swapping or switching the domain and range essentially when we create the inverse function, at least the parent function. All right, so now taking a look at the black function, you can see we've shifted the graph over 2 to the right. So now we know that x has to be greater than 2. That's our domain. And then y remains all real numbers. All right, so just a quick look at a couple translated log function, inverse log function, and then the relative domain and range for both the parent and the translated log function. That's it for the second part of Chapter 5.5. See you next time, the next edition of Otten Math.